G'day guys, been flat out, haven't been able to do many videos, but in this case I have a GPX 4500 that has come in for upgrades and modification, and another 4500 that has come in for upgrades and modification. And the thing that I find interesting is they're both 4500s, but I'm just going to move this chair so I can actually get in here and point and poke at things. Where are we? There we are. Okay. The difference, or one of the differences that you can see here is there. Notice the extra capacitors. Here, they're not. Here they are, here they're not. So this is basically, I'm just going to duck down and I'm going to put the right one with what. Okay. This one, yeah, I've got names and things all over the cases. I've got to peel these off, and I'll turn it around that way. Okay, that's the case, GPX 4500. Now, this one, I can tell you by looking at the serial number. I'm not going to put the whole serial number there because people will write that down and say it's their detector or something. So, but it starts with B100, and then there is 4 more numbers after it. So that's the sequence there on that one. I'll just put that back in the box. I don't really need to put it on the table. So this one here is B100 serial number. Okay, the other one, also, this one was please retain the security sticker. So yes, I did the magic on that, so I can stick it back down. As you can see, it's not damaged at all. But this one has the gain, right? This is the difference between the older and newer 4500s. The serial number on this one here is starts with 128, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits long. So 11 digits long on this 45. Now, why do people want the older one? Well, basically the newer one, this is I'm going to have to say this because it's in my opinion. The newer 4500 has the same board as a 5000. It's exactly the same layout as a GPX 5000, but it's a 4500. What my opinion is that they didn't want 2 production lines with separate boards at a later date. From when the 4500 first came out, they kept making them whilst the 5000 was out, and then they discontinued the 4500 at some point. But the later ones basically used the 5000 board and stuck it in a software program. You know, all the software's been programmed to be a 4500. It doesn't have fine gold, but The thing it does have lower front end gain the same way the 5000 does. So these basically, as far as I know, in my opinion, is just a 5000 with the software changed, obviously, and yeah, put out as a 4500. So a lot of people chase the older one because it has more gain. It has a gain, input stage gain of 48 on this one, and input stage gain of 34 on this one. So does that make a big difference? It depends. When I don't know the marketing, I never really pay any attention to what comes out of marketing departments with detectors, but something in the back of my head, if I am right, suggested that the second edition 4500 was quieter. Oh, yeah, I can guess why. And the 5000 was quieter. Yeah, compared to a first edition 4500, of course it's quieter. It has less gain. Basically, it is not amplifying as much, and thus you're not amplifying any target signals as much. You are also not amplifying any noise, um, any terrestrial interference as much, any uh, thermal noise, whatever there is, ground noise. Um, yeah, so basically it's less sensitive. That's talking about the input stage. It would be less sensitive. So what do we do about the low gain? Well, I'm going to run these two side by side in a minute. I'm going to do some tests. I'm going to not going to go and chew it all over with video on these tests. Let's just check something there. Yeah, I thought they might have changed the that inductor, but they haven't. But yeah, the boards are different. Basically, it's got a couple of extra transistors here on this version that, in all honesty, supply this IC here, which is just a quad op amp, with a higher voltage. I think it might be, I'm not sure what they raise. I think they might raise, normally this chip here has got plus and minus 5 volts on it. You know, that's how it works. It's split supply plus and minus 5, sorry, on this one. And this one I think is 5 plus 8. So one of the rails has been jacked up, which probably they wanted extra headroom for something on one excursion of that op amp for whatever reason. But that is the difference. Apart from that, it's much the same. Same chipset, must I say, in my opinion. Yeah, I don't think there's much else with it. The thing is that we can increase, or we can do it on any of the detectors, we can increase the input gain, but you do want to have control over the input gain. That's why when we do some of the modifications, when people request that they want variable input gain, that allows you to set things very close to the input stage of the detector. You can have very low gain if you want. You can have very high gain, because the gain control in the back menu on these things doesn't do the gain on near the front end. It does not. It's way back in the circuit somewhere, and yeah, it's a way away from this part of the circuit here, which, in my opinion, is all critical depending on what type of ground you're throwing at the detector to try and work on. Give you an idea, I'll see if we can point this out a little bit. Say you have one of these detectors and you're working on dry beach sand, inert soil, pipe clay, if you're looking for gold. You can crank the gain up like massively and get a lot of extra depth and a lot more sensitivity. And without it, you're basically locked. You are not able to get um, more grunt out of your detector as such. I'm talking about on the input stage, not in the back end after the horse is bolted. I'm talking about the front end. It's completely different. You can, by doing it in the front end, you can increase the dynamic range of the detector. You can basically improve the noise figure so that it will amplify very tiny sounds and not being lost in the noise, where if you crank the gain up on reactive ground with the same target, you'll swamp it and you won't be able to hear the target. There's a lot of things to take into account with these metal detectors. You just can't get one out of the box. And this is my own personal opinion. And and just say, well, one size suits all. It doesn't. It's not that way. So that's the difference on these. Now, what I will do on this one here, which is the low gain version, because I know that it is, I can measure it. What happens if I increase the gain here? You got to remember that the 5,000, in my opinion, again, right? Because if I say the wrong thing, I get legal letters sent to me over it, right? But it's okay to have an opinion. I've got to keep stating this. You are allowed to have a personal opinion, right? I can't go and say, oh, they did this and they did that because of that. And if I said that and it was slightly wrong, I'd get crucified over it. So I don't say that. I gotta mellow it out, right? I gotta mellow it out. And my opinion, I'll just say this: my opinion may be totally wrong, right? I'll put that there, but it's my assumption that my opinions are correct. But that's only my opinion on my opinion. Yeah, sounds funny, doesn't it? Anyway, that is the detector. So you basically got here, you got a 4500 with a what I would refer to as similar to a 5000 board. It looks the same, right? You can tell by the extra row of resistors here and that 8-volt rail powering that op amp. Well, it's a quaddy anyway. And you have a look at this one, it just doesn't have it. Now you can flip these things over and have a look at the other side. Let's flip them over. Now I think I've got that basically in view. I might get out, I might adjust this a little bit so it'll wobble and carry on. I'll never get a job as a film producer, I tell you. But if you have a look at that, it's basically the same. I'm just scanning, just seeing if there is any differences. Uh, the only difference that I can spot is on the what I classify as the 5000 version of the 4500 is two devices there, little SOT23 devices. I think one is a regulator diode and one is a pass transistor. It's to do with that 8-volt rail, but that's where it comes from. And if you noticed on this one, it doesn't have it. But in my experience and testing these detectors, and this is at the Talbot test site, in normal mode, normal operation, big gold, all gold, not fancy modes or anything. This one here, the original 4500, outperforms that by a fair margin. That's from my own testing. So that's what that has shown me. Side by side testing. It's this one here's got a lot more grunt on big deep targets. That one there is a little bit I don't know what we'll call it, a little bit pussyfoot on big deep targets. But it's good on small stuff. And like I said before, because the 5000 had fine gold as a mode, my opinion is that's why they reduced the gain to make that behave. I don't think fine gold is very successful at running extra gains or very fast clocking rates, because some of the pulses are very narrow, and when you clock it up, they start getting ridiculous. The recovery time and stuff is just too great, and it starts making noise. But there are limits. You can push them, but you don't want to push them too far. This is where I was doing on a lot of the early upgrades. I would give people the ability to adjust their detector. Um, Probably in some cases, if you cranked everything up, like you cranked up the gain and you cranked up the frequency and you put a crappy coil on it with high capacitance, not saying any particular type of coils, but if you tried to use fine gold in those circumstances, the detector would just desense and not pick up anything. So there is a limit. You can't go and crank the gain right up way over factory values. You have to bring it back a little bit, or you lower the frequency, or you can do both. But these days, what I've done, because people will try and crank everything, muck it up, and say, "Oh, my detector doesn't work." No, it's the driver. It's not the car, right? It's the driver. The driver's at fault. You've got to understand what you have. It's like someone got their license when they turned 18 or something, and daddy bought them a Maserati and they wrapped it around a power pole because they didn't know how to drive it. So same effect. You can't just go and crank everything and expect it to be perfect. You've got to know the limitations of the electronics and the devices. You know, Obviously, Minelab, when they make these, they have it so that everything is pulled. Well, let's say I'm not going. I was going to say pulled back, but what I'll say is everything is set that the complete novice won't get it wrong. You should not be able to get one of these wrong out of the box and set it up that it's. Well, you can. You have to get in the back menu and screw everything around, and you stuff your detector until you do a factory reset and get back to where it should be. But in the early days, that's what people used to do. I used to have people, well, people used to ring me up and say, "Oh, I've done this to my detector, and I can't pick anything up, or it's doing this." I've had people with some cases getting the 5000, turn the ground balance off, like, and and don't realise they've done it. And I always say, turn the detector off. Just wait a few couple of seconds, whatever, because the early ones, some of them used to blow up. There's a modification done, but anyway, some of them, if you turn them off and on too quickly, there would be a power supply issue, and smoke would come out of something. We can't even remember where it was. That's a high voltage, but yeah, it used to blow something up. Used to blow the power supply up, and they put a BAV 99 diode and a resistor, cut a track, and modified it. So some of the older units, the very first ones, have a modification done. They put out an engineering bulletin, which someone forwarded me for some reason. God bless their soul. And it showed to do this modification so it doesn't blow the thing up when you turn it on and off too quick. I don't think the newer ones, that's taken care of. That's been incorporated into the design of the board. So they don't do that anymore. But some of the old ones, it was a hit and miss affair. I've actually had it happen only one time in front of my face. I did it. I turned the detector on. I forgot to connect something on the board. I turned it off. I think it might have been the clip of the oscilloscope or something, and I clipped it on. I turned it back on, and next minute it went pop and a little bit of puff of smoke. And what it did, it blew up a switching transistor. Um, this is a long time ago. Like, I've done so many repairs and working on detectors since then, so I can't really exactly remember the whole scenario. But yeah, there was a fix for it anyway, and it's not a difficult thing. Um, it would maybe I've got that engineering bulletin kicking around somewhere. I should go and read it up. But the new ones don't have that issue, as far as I know. It's just one of those things. You turn it on, turn it off, and then turn it back on, and yeah, something was half biased or something. The capacitors were charged up, and it took something out. You could actually, if you really wanted to fix that sort of problem, if you got an old one, on all the capacitors, maybe on the 5 and 15 volt rails, you could put little bleeder resistors across the capacitors. Something like, I don't know, 1.5 k ohms or something like that. And when you turn the detector off, it just bleeds them down. So yeah, it's one thing, because these can hold the voltage up on one of the caps, and I think it is the 15 volt one. And then if you touch around here and short anything, the energy from that goes in and blows up the front end. So when the detector's turned off, mind you, it has done that. I don't know if it's actually been fixed up in later designs either. I don't know, but I know it's on the earlier ones that if you did something of that nature and the capacitors were charged up and you had the board sitting there completely unconnected, and you'd say, "Oh, I want to go and do something on the front end input MOSFETs here," that it would go crack and it would blow up. It'd blow that up. It'd possibly take out that BAV. Well, that's just a BC857 or something there. That's a fast speed up turn off for the MOSFET. It discharges the gates quicker. That the BAV 99 protection, that's driven by the ADG 333 here through a 100 ohm resistor for memory. One of these ones here. So yeah, basically you've got to be careful with these. So the capacitor that you've got to watch out for, if I know roughly where it is. I'm just looking. There's one's got a, oh, where was that? Oh, good. I found my long lost microgram scales, or Chari just found them for me. I was looking for them for ages, and she pulled them out of a drawer. Very good. Yeah, I was trying to see where that the one you want to discharge. Let's have a look here. And there we go. I needed to get realignment on it. Okay, I'm going to point with something pokey, guys, but you should know this if you're going to work on these. This capacitor here, that's its legs, and it's got that resistor through the middle of the legs, that one. You want to basically short from there to there if you ever do any work on these, because any residual charge in this capacitor here, which is basically under the 5 volt rail rectifier diode. That's what that is. That's your 5 volt rail comes out of here, and that one there is your 15 volt rail comes out. So if your detector's not working, you can always check for 5 and 15 here. But yeah, that capacitor there is a real nuisance. If that's charged up, I could probably hit a pair of side cutters across that now, and it'll probably spark. This one, I don't know if they've actually changed that at all. It may just sit there and hold the charge which is connected up through that speed up turn off device, and it'll get in there and blow things up. So make sure you always discharge all the capacitors. The other one's self-discharge through just leakage through the circuit, but I think that one that's there, just those that pin and that pin there, they're the ones that maybe if you really wanted to, you could put a small bleeder across it. That's only if you're going to fiddle with your detector and do things to it. But normally, if you're not going to fiddle with it, don't have to worry about it. But if you're going to repair it or something else happens, just be aware that anything you scrape something off or touch something, short something, it will blow up this. It'll blow up the front end. Then what you'll do, you'll say, oh, it's blown up. You'll replace your BC857. You'll replace your, it probably blows these up as well. So I've had that. It'll blow one or the other and you won't know which. So it could be open circuit or could go short, but just replace both 2SK1334s. Replace that BC857 there, and you're going to have to do the 2 input transistors on the other side because it'll take those out as well. What people do is they repair here and then turn the detector on, and maybe they replace the FETs, they don't replace the transistor here, and or damage any part of this. Next minute it doesn't time properly and they shove the flyback straight into the poor little 60 volt or 30 volt rated MOSFETs on the other side, whatever they are, and you have to replace those as well. Can also take out the BF908s, the dual gate MOSFETs as well. I've seen those crispied. There's a whole heap of BAV99 protection diodes there. It can burn those out as well. So you got to be careful if you do anything here, because this is the blocking for the flyback voltage. The flyback voltage, even though it's clamped at about 185 volts through that resistive MOSFET, and you've got your storage capacitor here. It's basically just a feedback loop to get the voltage stable. That voltage can easy, if these go short, bypass these, and this is after flyback. What do you think happens? You got 180 volts going into your damn front end, like in the front end. So you could lose your MOSFETs. It'll take out your AD797 input op amps. It can do a lot of damage. And I just had a look at the AD797s. My God, they are expensive now. They're getting up, I think I had a look at them at small quantity, $18 US each for an op amp. So that's very, very, very pricey. But they're probably one of the, they're not the best, but they are one of the better op amps. There are better ones out there. And yeah, anyway, that's that. That's well, that stopped me working. That's a big long video because people are asking about serial numbers on these things, and that's how you can tell the difference. So yeah, this one here is set up for lower gain. That's the way it comes out. I don't know if they've done any gain compensation otherwise in the circuitry, because it's all covered in white paint. You'd have to go around and you can't do it. I mean, you could, but you want to be there for a month doing it. There's ways of stripping this off, but I don't really advise doing that. Leave it there, and if you have to get on, just locally work on what you have to do, and then just cover it up again with a non-conductive inert coating. And yeah, I don't think there's anything else there. They may have, but because you can't get into the software in the Hitachi chips on these, or Renesas, whatever they're called, you can't analyze that part. You can only see the end result of that part. So that's what I'm going to do later on. I want to see if they actually have tried to increase the gain further back in the circuit on the 45 version of the what I call the so-called, in my opinion, 5,000 board. Or could they just reflash the software and make every 4500 like this into a 5000? I don't know. You have to ask them that. Don't ask me. But oh dear me, no, don't ask them. Yeah, no, I shouldn't say that, should I? Because it'll make people ring them up and harass them. But yeah, basically to me, it only looks like a couple of component values or a few component values are changed, uh, a few components are added, and the rest is done in software, in my opinion. So can can you can you get a 5000 chip and yeah, stick it in here, swap it, and see if it behaves? You probably have to do the back menu as well because it will say 4500, and maybe you haven't got the communication and the other software for the display. I don't know. It's that's too far and too deep to get into. So you could, but time is precious, and I don't really want to waste my time trying to do something like that when it serves no useful purpose. Well, some people would think it's a useful purpose, but I don't. If I had, uh, a well, I probably have an actual. I've got 4 or 5 4500s of my own because they're a damn good detector. I tell you, they go deeper than things with lower gain, and also the 45 with the lower gain setup board. But I want to check to see if they've jacked up the gain later on, because in the later versions, the gain range is different. I don't think it's really 1 to 20 or whatever it goes to, and the others are 1 to 15, I think, for memory on this one. But I think I don't know if it's actually extra gain or just expanded the scale on the gain. You know, um, I don't know. Like I say, in my opinion, might be just a trick from the marketing department. I don't know, no idea. But I can prove it out if I really wanted to set these up and just do some side by side comparison testing. How about I will do that? I will do that. And if there's any massive difference, I'll make a video about it. But if it's, you know, they've just, you know, have no gain jacked up, and it's, it is what I would call a poor second choice to the first one because of the low gain on it. And if it's not jacked up and it just expanded the scale on the back display, well, then maybe we should mention that. And there's ways of fixing that. In the little lab here, we can fix that up. But you don't want to go and jack up the front end gain when they've boosted it in the back, and you're going to end up with a dog's breakfast. You don't want to do that. So, however it's set up, really have to analyze it. Have I got? Yes, I have. I've got my own 5000 too. So um, I might have to clear the bench down and do a big side by side test, and we'll just see what we got with these detectors. What's what and who's who, and what does what. But anyway, that's how these things are. So I've got to do these. I shouldn't waste my time. I want to get these done and finished because people are chomping at the bit for the detectors, and these will both be deep going detectors. Everyone's running around the place looking for fly specks, right? The detectors are all set up looking for fly specks. All you're going to find is fly specks, right? Within reason. You really want to, uh, yeah, you want to get into the deep modes on some of these detectors when you can run all your own coils. You don't need dongled coils, and you can go and put 25-inch coils on if you want. And there's a big supply of coils out there. So that's the way I look at it. I don't like the dongle idea. I really don't like it. It really displeases me because it's yeah, it locks people. Well, does it really lock people out of the market for making accessories? Because I think nearly everyone that's got a 7000's had the cable chopped and an adapter made to run X coils. We'll give X coils a plug. Uh, so that's not very patriotic, is it? But yeah, so many people run X coils on their detectors, even the 6000. People have done things to run X coils. So this dongle idea. It's if people are really determined, they get around it, and you know it's just what's ended up happening. People can get around it. You get around everything if you want to. It's like it's like why are there software upgrades for security? Because the hackers are always one step ahead, and that's how it works. The hackers are always one step ahead, and they've got to then always chasing what the hackers have done. So same with detectors. You go put dongles in plugs and dongles in coils and things. Well, guess what's going to happen? The company's going to say, "Oh, they got around that. What are we going to do next time?" Uh, how do we stop people putting other coils on our detectors? Well, how about the person who bought it should have the right to do that? You should have the right to do that. And don't start me on it, but there's another thing that's coming out. It's getting a lot of look at the moment, and it's called right to repair, right? And this is going to be very interesting on some devices that have modules placed in the circuit boards that are unrepairable, right? This is going to have an impact somewhere down the road. Right to repair. Uh, so look into that. Look it up on Google. Right to repair, and have a look at the legislation that's pending. This could get very, very interesting for some companies. I'm not saying any names, but yeah, you can do the research yourself. Don't take my word for it. Get it from the horse's mouth, not third hand. But anyway, all this has been my opinion piece. Uh, of course, it's my opinion piece because I really don't know, do I? I don't know. It's an opinion. So, um, yeah, that's that. Oh, I think I've bloody waffled on long enough anyway. What have we been going for? Whoops, there goes the drill fell over. My electric screwdriver. Oh, it's 38 minutes of waffle. But anyway, guys, if you wanted to find out what boards what in what, now you know. I'm just going to have a look down here at something too. Where's my... Yep, my original GPX 4500, which is, oops, that one there, that has a serial number of just 100. Starts with 100. No B number, but this is an early one. So just a 100. And the other ones were B. It probably designates, maybe it designates what factory it came out of. Hang on a second. Let's look at a few more down here. Where's my 5? Oh, this is interesting. Okay, my 5000, which is still in bits, getting things done to it, of course, you know why, is B800. So my 5000's B800. And I'll have a look at this one here. This is really old. This is no ears. And no ears is an original 4500 without all the extra doobie doos on it. Yeah, serial number starts with 100 again. So I think you want to take note of that. That any 4500 with a 13-digit serial number, probably low gain. The B100 probably has normal gain, and just a straight 100 series has normal gain. But yeah, I don't run around looking at serial numbers. I just look at the insides of the detector and determine what's what. So hopefully you big gold hunters out there who want to use these detectors now have more insight to what does what off the shelf. If you do see one with the serial numbers, you'll know its capabilities as to if it's high gain or low gain on the front end. And if it is one of the other and it's cheap, we can always upgrade it for you. We can do, there's lots of upgrades we do. We can do hidden upgrades on the board to give you more performance so that no one knows that it's going to kick them on a side-by-side test. There's a lot of things we can do that, we don't need to run external switches and knobs. We can do a lot of it on board. That's what we've been finding a lot of people want. But if you want the full works, you will have to have a control such as, which I've got mine out of my 5000, but I'll grab this one down here. Here we go. Here, I'll grab no ears. So if you do want variable gain, it does need another control. You can't get around it. You can't do it in the back menu. Front end gain, you have to do it like so. So you can set the gain wherever you want. But like I say, you can do a lot of it without doing that and have it all hidden. It just looks like a normal detector, and you're the only one that knows of the extra capabilities. So that's where we're going with detectors. I could go and put switches and knobs and stuff, or it just confuses people like crazy. What's this switch do? What does it do in conjunction with this other switch and this knob? And you try and minimize the outside stuff. Like, I used to do F1A4s, and I gave up doing F1A4s because there's so much things people wanted, the requests, and you had to go and put four extra knobs and extra switches on it, and just confuses me. So, or didn't confuse me. I should say confused people who had to use them, and it wasn't really geared that way. Don't buy an F1A4. Get something like one of these, and just if you want my honest opinion, just get yourself a 4500, right? Get the full stack of mods done to it, and it'll go like unbelievable performance. Small gold, tiny gold. You can work any ground you want. You can run any coil you want, size-wise. You can run double Ds. You can run great big whopping huge monos. You can get everything second-hand on the second-hand market, dirt cheap. You don't have to go and spend, somewhere up near, or over $10,000 on a proper prospecting setup. You can do it well under $5,000. You can, if you just want to go completely dead stock standard, you can pick these things up. They're all over the place. I've seen 45s down at $1,800. I've seen them up around 3.6. I've seen 5,000s at 4. I've seen them down to about 3.2, and and everything else in between. But there's nothing, like I say, marketing people hate me saying this, but there's nothing wrong with the older detectors. There's nothing wrong with them. They work perfectly fine. And if you're going to be running around with a little VLF fly spec machine, well, that's what you're going to get, right? You're going to get fly specs. All the look, I've had this is getting extended, but bad luck, or good luck if you're interested in the information. I've had a lot of people lately basically say to me, "Oh, all the gold's gone. It's all gone." No, it's not all gone. It's not all gone at all. There's just too many people running around in fly spec mode, um, and just picking up breadcrumbs. But the big, deep stuff, like you saw that fellow who found that big nugget, what, a couple of weeks ago. If you had a look on the news, have a look at Big Nugget Ballarat, and it'll show you a big nugget. Uh, um, yeah, Days Minelab dealer here in Ballarat put a post up on Facebook too. 2 kilogram nugget. It's from some time ago, but it's a nice looking big slug sitting on the kitchen scales. And that sort of gold, you do not run around and find that, using an 8-inch coil or a 6-inch coil. That stuff normally, and I know people who found big gold. Oh, it sounded like ground noise, right? That's what they say, and a lot of cases people ignore that. Well, the signal was very soft. Oh, I thought it was something small, but some of them persevere and dig it, and they have these massive, great whopping lumps of gold. So that's the thing about getting depth. Like in that situation, if the ground is mild, you want a lot of gain, so that little tiny whisper becomes a little bit more pronounced. That'll make you dig it. So these are the guys out there who know what they're listening to, and then they'll dig it, and they're the ones that get the big gold. Everyone else has been tuned into fly spec mode. I'm going to say something else starting with the S word, but we'll call it fly spec mode. And yeah, they go out and hunting. Like for some reason, the mentality's changed. That all the big gold's gone. No, it hasn't. It hasn't. It's still there. I'd tell you, I know spots. I know I can. If I can get away from the workbench, I know for a fact I can go out there and get big gold. I know for a fact because I've done it. So there's a heap of places I want to do, but I can't just shut up shop and say, well, I'm not doing anyone's detectors for them. That would be a bit of an outrage, wouldn't it? So, and like I say, I'm always, you can see I don't know if you can notice it there, but you have a look at I'll crank this up, my 5 in the background there. That's got a whole heap of stuff done to it that has really been a lot of work done on that. And that's, yeah, I want to go out and use that in the bush too. That's absolutely, that's a pinnacle of perfection, that detector. I've just got to do a bit more work to it and get it back together, but it's an absolute doozy. So anyway, we'll leave it there. It's 48 minutes of waffle. Catch us later.